Okay, so I think we all we'd all like to take a moment after Chris's presentation to kind of just take that all in. But we still have one more presentation, and then we'll be able to kind of let our brain process everything that's happened throughout these almost 2 days, and give ourselves a chance to, just put it all together and let our brain connect the dots, because it does that best when it has a chance to, just look into this sense, empty-eyed, seemingly thinking of nothing. So it is my pleasure to introduce our last speaker of the day, who is about to share one of his stories as well. It's a presentation where the crypto world and cybersecurity meet. Obviously, they're deeply connected. They're extremely important for each other. It's just what we've been talking about throughout the past 2 days. All of the systems are interconnected. They are, they depend on each other to work, to thrive, and for us to be able to use them and thrive ourselves. So, Anatol Prisakariu, welcome to DefCamp. You're a longtime friend, longtime contributor, longtime super involved member of the community. And I'm excited to hear all about, how to rescue compromised wallets, which is, and I have a sense that it will be a bigger and bigger problem.
Hello, Andra. Nice to meet you. And yes, I'm involved with DefCamp for a long period of time. Been there for a while and organized competitions, CTFs, and all that. My new journey is crypto for the past 2 years at least. So I've seen a lot happening, and of course, having a security background, you cannot not notice the amount of hacks and everything that happens in the space. So let's try to share the screen and begin the presentation. There we go. Can you see it?
I can, and everyone else will be able to in just a second. So please go right ahead, and we'll make sure that, yep, there you go. The stage is yours.
For me to go through this presentation, as I'm going through these presentations, I'll have to first explain what MEV is, and then we'll get to the actual story on how to use MEV to basically rescue huge amounts of funds from compromised wallets. So first about myself, I'm the founder of Security Espresso community. It's been already a few years since we've been organizing workshops and meetups and all that. I'm a security researcher. That's my. I started as a developer and then moved to the security field. I've dabbled with web, Linux, mobile, and lately with the blockchain. As a developer, I started actually using PHP in the very beginning, and then switched to JavaScript. And so lately, but I still use whatever it takes to do the job done, to get the job done. And previously, I spoke at DefCamp, at Volga CTF, OWASP, DevTalks, and other conferences, INFOSEC, UAB, etc. At a lot of meetups. When co-organizing DefCamp, I was in charge with DCTF, DefCamp Capture the Flag competition. I think I was the one that introduced Wi-Fi Palmboard, or at least I was one of the guys who worked on the current version that we had when we had live conferences. And I was involved with Hack the Bank. I can't wait to get to a physical conference and actually get back to organizing these competitions that take usually on site. And I'm a coffee addict. I have to confess about that. So who is this talk for? First of all, it will be helpful for blockchain developers because they will be aware of what's out there and how they can defend their applications. Secondly, it's for security researchers. When performing audits, they would be able to detect things more easily if they would be aware of, again, what's happening in the space. It's for users because they will be the ones that will be that might be affected by some negative aspects of the system. And of course, we cannot exclude the arbitrageurs that make a lot of profit out of this using these techniques. So the MEV tail starts with arbitrage. Basically, in the beginning, when the blockchain was born and we had decentralized exchanges, someone could buy a coin for some amount and sell it on another exchange for a bigger amount, and he would be able to pocket the change. So to illustrate this, I have the screenshots of two exchanges. So basically, if you swap one ETH for Avi token on one website, you get that amount. And if you sell that amount on a different exchange, you might get a slightly bigger amount of ETH. So you can basically pocket the difference. So in this example, the gross profit was 0.007 ETH. But this was just a random example that I stumbled upon. It happens all the time. And if you monitor the blockchain a lot, and you see these opportunities, you can send a transaction. From the profit, you subtract the gas fee, and basically you pocket the profit. It looks simple, and just like that, you shoot your shot, and you can profit. Of course, you may maybe not the only one that does this, and someone might outbid you. Maybe your transaction came the second in the block and you lost money or something like that. Or maybe you took care of the exchange for the transaction and had an early exit in your contract, and you spend the least amount, but you still spend something on the fees. So in order to basically, if you're shocked, in order to do something about it, what you can do is actually analyze the pool, find the TXs that want to perform the same trade, outbid them in the gas price, and then you'll come in first and you'll profit. Okay. So what people did at that point, they took a look at the mempool. The mempool is a place mempool stands for memory pool, and it's a pool of transactions that aren't mined yet, but are in the memory of the nodes. So everyone has these transactions and is trying to mine the next block. And the way miners do is basically arrange them by the gas price. The first profitable, go into the block, the most profitable ones, then the others. So whoever sends higher gas price will be the first in the block and will win basically this. And if you monitor the mempool and see another transaction that wants to perform the same trade as you basically can send one with higher gas, and then he can see your transaction and outbid you. So this is what actually led to the great gas price wars. Of course, this is not how it happens on the blockchain, as you can see on the screen. It's just for illustrative purposes. But the gas wars, or how they are also called priority gas auctions, happen on the public mempool. And as arbitrageurs send their transactions, when they see that another bot have sent a transaction, send one with a slightly higher gas price to outbid them. And this goes back and forth until the block is mined, and then they have to basically fight for the space in the next block, and so on until they, as long as they have opportunities. So there was a paper on this, and in the Flashbots 2.0 paper, basically there was an analysis of the priority gas auctions that happen on chain. And you can see on the screen that we have basically two bots. First one is the blue one, and second one is the green one. And they outbid themselves for almost 14 seconds. We're sending transaction after transaction in order to win the gas war. Unfortunately for them, the competition was won by the green one, and it ended quite early at 5 seconds. But this thing happens and spams a lot the network in order to it has a high toll on performance toll on node operators. Another thing that happens on the blockchain, maybe you have heard of it, but it's a sandwich attack. So it's not quite like in the picture again, but since the transactions are in the public mempool, for example, if a user sends a transaction with a gas price and wants to swap one coin for the other or one token for the other on some exchange, if the user sets a slippage in the transaction that's too high, basically a slippage is the tolerance for the price movement of the token. And if the users allows a gap that's too big, then bots can come and take profit of that. How do they do that? Basically, they see your transaction where you want to buy. They send one with a slightly higher price where they also buy the same token, so they increase the price. Then your transaction happens, and afterwards they do a second transaction when they sell. So they basically force you to buy the token that you intended at a higher price, and all that's because of the slippage. In reality, what happens is that bots don't just add one GUI, they spam with lots of transactions just because there are a lot of them, and they just spam the nodes in hopes that they will be the one that will be picked. Again, this has a performance toll on the nodes. To illustrate how again, as you saw, I have illustrations for all the examples. So to illustrate what a sandwich attack would look like and would be in a much intuitive way, you can think of it like this. Basically, a sell order, a buy order, and the trades that you wanted to do, but your finger slipped and you let the slippage way too high. Anyway, if we look at the transaction on the public blockchain on a block explorer, in this example, I have Etherscan. You can see that there are two transactions and one swap transaction in the middle. The first transaction is basically the buy transaction, and if we look at that, you'll see in this example we have the Cent token. I never heard about it, but there are a lot of tokens out there. So in the first transaction, the bot has purchased 10,000 tokens or something like that for 7 ETH, 7.02. Then came in the transaction that actually was intended by the user, and he bought the amount that he wanted. And then the bot came and basically swapped all the tokens that he previously purchased for slightly more ETH. In this case, it was 7.10. So basically, the bot was able to sandwich the transaction and extract value from it. And for users, if you set a high slippage on your transactions, you'll almost sure get sandwiched. Although not almost, but surely get sandwiched if you use this on a public mempool. Now, since the bots have started to send a lot of spam to get this right, and basically have the transaction before yours and after yours, and there were a lot of competition in this, this basically led to a lot of spam in the network. So to prevent this, there were two main ideas that helped a lot. First of all, are private transactions. So if we have the regular nodes, when the user sends a transaction to the node will basically broadcast that transaction to all other nodes. They have a special protocol for that, and it's called Whisper protocol, and they basically broadcast as soon as possible all transactions that they get. And if someone wants to front run or sandwich that transaction, he would be watching the mempool that's public and offer the higher TX and get in front of the transaction. However, with the private mempool, in this case example, I have one operator type Shiba that I don't think works anymore, but we have others now. We'll get to that in a second. So with a private mempool, if the user Alice sends the same transaction to the node will not broadcast it, and front runners cannot observe the mempool because it's private, and they cannot front run you. So that basically gives you private transaction where you can set your slippage in a bad way and you won't get wrecked. Of course, this doesn't mean you can just go YOLO on the blockchain. These transactions are almost private because once it's mined, it will be included in a block and anyone can see it. So if a rework happens, basically your transaction is back in the mempool, and people can take advantage of that. A rework is an event where let's say we have a chain A, B, C, D, E, and then a miner came in and mined the top of C, D prime, E prime, and the F blocks. Since the second case is a longer chain, the network will trust that as being the canonical chain and will choose that. So everything that happened in D and E will be back to the mempool and mined again. So the second idea to contravene the gas price auctions and all that is to basically bribe the miner. There's no incentive for the miner to keep the transaction private unless we bribe him to do that. Since we are bribing him, we can not only send a transaction, but we can actually send multiple transactions to the miner, and he will keep them private, will not broadcast them to the other nodes. And we can also take advantage of this process and tell the node to execute them, include them in the block in a specific order. So this brings a lot of power to the miners and the people that use those RPCs of those miners. This is basically what Flashbots did. Flashbots is an organization that forked Geth basically and implemented all this logic and called the client MEV Geth. And most miners actually nowadays run MEV Geth because they are able to accept bundles from searchers being people that submit bundles. And I think all the arbitrageurs nowadays use our searchers and are using Flashbots or other services like this. And MEV-GET basically adds a new call, ETH call bundle and ETH send bundle, two new calls, which you can use the simulator bundle and then submit your bundle to the network, and the miner will not broadcast them until it's mined, and you have the transactions in your order. And because you bribe the miner at the end, you could actually send the initial transactions with a gas price of 0. So basically it was free gas. And to take a look, if you take a look at the number of pools that we have out there, basically, aside from a few of them, most pools are running MEV-GET, and they have the majority of the hash rate. This image is back from May. It might have changed a bit. Spark pool is not around anymore, but you get the idea. So what about the free gas? So basically, if you have a transaction and you set the gas price to 0 and you send it to a public mempool, no node will want to include that by default. But if you send a bundle of transactions or send one specific transaction that includes a bribe to the miner, then there's an incentive for the nodes to include it. So basically, you can use this to your advantage and avoid paying for reverts, because when a revert happens, if your transaction fails, you'll have to pay for the gas. But using this trick, basically, it's free transactions and nothing goes in, profit goes out. However, this specific free gas scenario didn't last for long, and back in August we had EAP 1559 that had a goal to make the gas prices more reliable, and as part of it, it basically burns a part of the fee that that the user sent instead of sending it entirely to the miner. So you have to, we have much more reliable gas prices now. Base fee is required and is burned. So that's why there's the rocket out there. And that's why people call it ultrasound money, because it becomes, or soon will become deflationary. So more and more expensive. And you still can submit your transactions, but as long as but you have to pay the base fee, because that's a requirement now, and you still have to bribe the miner. So there's an incentive for the miner to basically execute your transactions in the order that you choose. And if some transaction fails, it won't be included, so you don't have to pay for that. That's taken care of Flashbots. And to observe Flashbots, you can go to Etherscan and open a specific block, and almost all blocks will have this labels, Flashbots and unconventional ordering. Unconventional ordering referring to the order of the transactions in the block, because they're not ordered by the gas price anymore, but it's just as you set them to be. And back until August, you would notice this kind of transactions. You'd have a swap in the middle that pays the gas fee and all that, and you'd have two transactions, two other transactions, one before it and one after, that had the transaction fee 0. And curiously enough, opening one of those, you would see exactly this. Now with the new Flashbots, you cannot get them for free, but you still have cool stuff. So about those rescues, as you all know, since it's crypto, it's based on cryptography, and every wallet has a private key or a seed phrase. So basically, all accounts have a private key that's derived out of the seed phrase, and that's basically the security of the wallets. If you leak this, anyone will be able to basically drain all the funds that you find there. Good luck with the this SID. It's probably drained already. Okay, so obviously this creates an incentive for the scammers, and they would basically create all kind of fake websites where they would try to trick you into entering the seed words. And if you just happen to not pay attention and enter your seed on that website, as soon as you do that, it's gone. You don't have it anymore. Everything that you had, all the ETH, all the tokens, everything is gone. So what happens is sometimes scammers do not notice that people still have some tokens or some amount of money or something staked on some protocols that don't show up in the wallet itself. So at times they will be like, oh, maybe they didn't notice, maybe I still can get it back. And that's when people are looking for help to rescue their wallets. How does this happen? So basically, if a wallet is compromised, all the ETH from that wallet is swept away as soon as it arrives. If you try to fund your account so you can send a transaction from it, you won't be able to, because immediately as it arrives, it's gone. And if you manage to basically send a transaction to fund the wallet and then send another one that wants to transfer the money out, unstake or something like that, then scammers might notice it and might actually be faster than you and unstake and steal the money. So you have to be as quiet as possible. So that's a perfect use for Flashbots, where you basically can create a bundle with a few transactions. First, it will be the funding transaction that will send ETH to your wallet. Then you do all the transactions that you need to unstake, transfer all the tokens that you have there, etc. Then you obviously have to bribe the miner, and you put this all in a bundle, send the bundle to the miner, and the miner, if the bribe is high enough, will include it in an upcoming block in the order that you specified. And as soon as the block is mined, you have all the money, and the scammers cannot do anything unless there's a reward, of course, but that happens not that often. And you can repeat the bundle in that case, hopefully. Once you get the funds out, happy Pepe. So to learn more about the MEV, you can go to the Flashbots website. It's on github.com/flashbots/pm. You also have on GitHub the MEV-Geth. It's open source. Anyone can take a look at the code. You can use the Flashbots provider with Ethers. That's on a JavaScript library to interact with the blockchain. You can watch the stats about Flashbots, how much money they made, and that's basically tracking the MEV extracted. And you can join their Discord to take a look around and chat with them. So the takeaways from this presentation is that miners can and will manipulate the order of the transaction. For developers, the takeaway should be that you should not rely that the person sending the transaction is not intending to do something with your application. If you have a few transactions, one after the other, they can manipulate your contract and do nasty stuff. But we can use the Flashbots, the MEV-Geth, in our advantage, as you saw before, and actually perform rescues and do other stuff like just-in-time liquidity that I didn't get to talk about, but we'll talk about on Twitter. So keeping that in mind, keep calm and hold your...
Thanks so much, Anatol. That was really detailed. And I think that it just, incited even more curiosity into the topic than people already have.
That's the goal.
That is absolutely true. Just because we're getting ready to wrap up DefCamp, but I hope you'll hang on with me for just like 2 more minutes. I wanted to ask you, what role has DefCamp played in your personal journey, throughout the phases of your growth in cybersecurity and beyond?
Well, obviously, everywhere that we go, every field that we choose, it's all about people. It's about the people that surround us and that will basically we will interact with and form our skills and find opportunities and talk to and share ideas. And DefCamp was the perfect place to meet other security researchers and share the knowledge and learn a lot more that anyone could do on his own. And I'm thankful to the DefCamp team for that opportunity. I am great. I'm glad that for all these years I was part of it.
We're glad as well, and we're more than happy to celebrate your achievements and your insights, and continue to learn from you as you make your way through whatever you want to do next. So thank you so much, Anatol. It was such a pleasure to have you.
Thank you, Andra. Pleasure to present.